Another video. In today's tutorial we'll be taking a look at extracting source code from Python binaries. So before we get started we'll just need to download some scripts from GitHub. So just open up a browser, go to this URL. I'll put the links in the description so you can download them. And this script basically extracts the Python PYC files, which is the Python bytecode stored in executables. So we're just going to git clone that. And say git clone. And that should be done for us. And we'll also need another program as well called decompile++, which this script basically just extracts the original source code from the PYC file once we've got it. So we just need to extract that and git clone it. So that should be done for us. So before we get started, we'll just need to download some additional software packages. I've written down all the packages here, so you can install them. Now just open up a terminal. Obviously I've reinstalled them for the tutorial here, but if you haven't, just do sudo apt install patchelf cmake make nettools python 3 -pip, and then enter your password. And as you can see, those have been installed. And we also need some additional Python packages to install that. And pip3 install pyarmor nutka and pyinstaller. Okay, those should be done for us now. So we'll just head over back to the main directory. And I've just got some Python files here that I've added. You can add your own if you want to. But essentially we'll just need to compile the Python scripts into a binary using pyinstaller. So to do that we can do pyinstaller -f, which just creates a standalone binary, followed by the script name, which in this case it's genhash.py. And once this finishes running, we should have a compiled binary. So if we go over to dist, that's our compiled binary from the Python script. So I'm just going to copy that to the main directory. Go to properties, click on permissions, make sure it's executable, and I'll just run this binary just to make sure everything's working. And it looks like it prints out a password and a hash. So we'll try and see if we can extract these values without actually running the binary. So now that we've got the binary, we can go to PyExtractor, and the command that we need to run is python 3 copy over the Python script. And we'll also need to copy over the binary file so it can extract the PYC files. So that's done, and this is our path where it's stored. So we'll just navigate over to there. See, we've got a file called folder called genhash extracted, and we've got a file called genhash.pyc. That's the Python bytecode that we need to decompile. So let's go over to the decompile++ folder that we downloaded, and we'll need to build this from source. So to do that, you can do cmake dot, and we just need to run the make command, and that should build and compile all the files for us. So that should be done, and you should have a executable file called pycdc. We're just going to go to permissions, see if it's executable, and it is. So to use this program, basically just need to go /pycdc, and then we just need to supply the path of that genhash pyc file, and we should be able to extract the original source code from this file. So it looks like it's extracted the original source code. Looks like we've got an import for a repository called hashlib, a variable called password, and this is the original password that has been included in the program. We've got a variable called salt, looks like this is the salt here, and then we've got another variable which is just combining the password plus the salt. It's printing out the salted password. There's a hash function creating a hash from the password and the salt, and it's printing out the password plus the salt and also the SHA-512 hash, which is what we saw in the original program. So you can see here we're able to extract not only the source code, but it's got a password and a salt stored in plain text. So obviously this is if you're writing Python coding storing sensitive information in binary, yeah, probably not the best thing. So obviously we can do this with Python binaries that store sensitive information, and if you're reverse engineering Python malware, then you can also use that to figure out how everything works. For example, I've got some malware here that I've created, so we're just gonna follow the same process here. I'm just going to quickly convert this to a binary, and we're just going to see if we can extract the source code from it. Now we just need to extract the Python bytecode from the binary again. Just run it. That's extracted the code for us. And we'll just need to copy over the path from the original binary. And got the wrong file. Needed to copy and paste the Python bytecode. And we've also got the entire source code for this file here. Looks like it's importing some libraries called socket, SSL, subprocess, and OS. Looks like it's sending a request to another computer. We've got another IP address here, 10.1.1.102, and a port it's listening on is 443. So it looks like that's definitely malware. It's trying to execute commands on your system and sending the data over to another computer. And sometimes it can't retrieve all the source code, so you might run into this error, but still we've got the kind of point of the program. So that's how to extract source code from Python binaries. Now if you're looking for a way to obfuscate or encrypt the sensitive information, what you can do, go to the original source code here. I'm just going to delete these. So what you can do is use a program called PyArmor. To do this, you can do PyArmor gen and the name of the hash, the name of the script, which is gen_hash .py. So that should have obfuscated our script for us. And if we open this, you can see we've just got some encrypted bytecode here. So we'll take this, run it through PyInstaller. -f and then gen_hash.py, and that should build our script for us. And we should have a binary in dist. You can see we've got gen hash. So we'll just try and decompose this and see if the result is going to be any different. And we're just going to copy over the binary here, just run it, and we should have that information now. I'll just run a strings command on it, see if it worked properly. Yeah, I reckon that's worked. So we'll just go over to decompile and try and decompile the source code for it. Okay, so this has decompiled the source code for us. So it looks like, yeah, we've still got that encrypted bytecode here. So as you can see, we weren't able to retrieve any sensitive information such as passwords, salts, or the structure of the program. So that's a good way of protecting your source code. Now, obviously, this method isn't completely unbreakable. I'm sure if someone spent enough time, they could probably decrypt it. But it's better than having plain text stored in a file here. And another method that you could use to protect the files as well. There's another Python library called I think the program was called Nootka, and that basically converts the Python bytecode to a C executable. So obviously C programs are a lot harder to decompile than Python programs. So an attacker would need a completely different skill set if they wanted to try and do that. So what we can do here, we can do Noot. I think it's Nootka 3 standalone. And then the Python script. If I can remember the syntax for it. Basically just add --1 file. That should work. And that should compile our Python bytecode to C file types and then compile it into a C binary. This might take a couple of minutes depending on how big the file is. So yeah, we'll be waiting a bit, I think. Okay, that looks like it's worked. And we've got a file called gen_hash.bin, so this should be the seed program for us. So I'm just going to try and decompile this and see what it says. So looks like I've tried running that extractor script, and we're not able to extract any information from it due to the fact it's a C program file and not actually a PyInstaller archive. So that's already a good step in the right direction. And so if you're really keen on protecting your source code, you could probably use a combination of the PyArmor and the Nootka library. I know they have some paid versions as well, which offer a little bit more security. So you could always purchase those if you wanted to. So that's pretty much most of what I wanted to show in this video. And I suppose the only other thing to mention here, if you're not too sure if you've got a Python binary or not, you can just run the strings command on the terminal. And if you go right to the bottom, you should see some directories like PyData. You should see some libraries such as CPython. So that's a pretty good indication, as well as the .pyz file. That's a pretty good indication that it's a Python binary. So you can run those on the executables, see if you're able to run those through the PyExtractor program. But yeah, that's pretty much it.